Oh, you're online. Go ahead, David.
Okay. So thanks for having me on your meeting today. I haven't actually been involved with anything with Brian's Quant Lab before, so this is a first for me, and I hope I can make this interesting. So I've got some notes in front of me, so you'll see me looking down.
No worries.
A lot. All right, so firstly, who am I? David Dight. I live in Sydney, Australia. I've been in the finance sector almost 25 years now as a developer. I've worked for lots of big organisations over the years, including NASDAQ, IMEX, Standard & Poor's, Deutsche Bank, also for various exchanges, mostly on the sell side. So I've got a long history in the industry, and over that time I've mostly been working on messaging platforms, trading platforms, and fix engines, and that's probably my interest over the years has evolved mainly around fix engines, and so that's sort of what has brought me to develop Fixate. Some of you have probably used Quick Fix or probably heard of Quick Fix. It's certainly probably the only open source fix engine, C++ fix engine that has sort of got any traction. There have been a few others, but Quick Fix certainly is the most popular. And I guess Fixate is a more modern attempt at providing similar functionality. So Fixate evolved really out of my own sort of frustration and limitations with Quick Fix. And I started the project about 3 years ago. And last year I released it. Now when I started Fixate, I didn't really imagine that I'd release it as an open source project. I sort of imagined that I'd be able to commercialize it. But I realized that I didn't have the resources to do that. And I've got a full-time job and a family and a life, and I just didn't have the time or the commitment to try and make a commercial product out of it. So I decided to make it open source. So that's a bit of background. So what is Fixate? So it's a fix engine, and fix engine provides basic fix connectivity between market participants. Now, I'm not sure how many of you have used Fix before. Generally, it's provided by sell-side organisations, exchanges, and sometimes brokers who are providing straight-through processing. But Fix is probably one of the most popular protocols used between market participants. There are a lot of proprietary protocols out there, but Fix is probably the most well-known and well-used of the more open protocols. It's also very simple, not without its problems, but it's still a relatively simple protocol. So Fix8 is basically a framework which provides fixed connectivity, both in client and server mode. So let me see. Where should I go from here? Okay, so how does Fixate differ from something like Quick Fix? One of the main differences between Fixate and other fix engines, including Quick Fix, is that it produces code based on an XML schema which describes all of the messages and fields that you might use in your session. So Fixate actually is two parts. The first part of Fixate is a compiler which takes a fixed XML schema and generates C++ code, and that code is then incorporated into your application. And the second part of Fixate is a runtime library which you link your application against. Brian, can they see this screen here?
Yeah, we can all see it. I can see it. Everyone can see the screen okay? I think everyone should see it. Yep, Bart says yes.
This diagram here basically describes what I was just talking about. Basically, you start with an XML document, and XML schemas are pretty widely available for a lot of exchanges. Some of them are proprietary or require NDAs to be signed. Some of them don't. Some of them are openly available. In any event, an XML schema which describes every messaging field that will be used in a session. So the compiler takes that schema and it generates C++ code. And that code completely encapsulates the schema in C++. And then you write your application and you link, or you compile both the generated code and your code. And then your final application links against the runtime library, which provides all of the services and functionality needed, such as session management, logs, logging, persistence, etc. The sort of things that you need for a session. So it's a sort of a different approach. The proprietary fix engines tend to write bespoke implementations for each fix variant, and they highly tune those implementations. So they will offer, for example, a CME 4.2, fix 4.2, and that's, if you've got the resources and the time and money, that's certainly a good way to go. But because the Fixate provides a more generalized implementation, I've taken a step back with that and said, right, well, you can define your fix schema, and Fixate will generate code, and you can then optimize that code if you want to and improve it. But it provides a much more generalized framework. Now, Quick Fix also provides a similar framework. However, the fix schemas are predefined. You can modify those, but they're interpreted at runtime. They're compiled, if you like, at runtime, and they're used dynamically. Now, in my testing, that's actually less efficient than compiling the code statically, generating it statically and compiling it into your application. And in my testing, when I've compared Fixate and Quick Fix, that accounts for the major difference in performance. So what I'm hoping with Fixate, with this model, is to really target the high frequency, low latency space. And it's early days yet, but the performance of Fixate is still not on par with, say, the Beta or Onyx or any of the other commercial engines, which, there are some very good ones out there. But my hope is that I can reach some of those performance numbers, the low latency numbers. So that's a description of how it actually works. Let me just go back over here to the performance. So I mentioned about performance. Can you read this? Can this be read, Brian? Or is it too small?
Yeah, you'll probably need to blow that up.
Blow that up? How about that? Yeah, it should be okay. Yeah, Bart says it's okay. Okay, good. So performance is, apart from flexibility, one of the design objectives of Fixate is to be highly performant. And with Fix, your main area of latency is encoding and decoding. As with most messaging systems, it's the encodes and the decodes which tend to choose CPU cycles, all other things being equal. So I mentioned quick fix. So here's some comparisons tests done between quick fix and Fixate. Some of you may already have seen this site, and if not, bear with me while I just go through it briefly. I've got two almost identical applications. I'll just expand that. That's the quick fix code. And anyone who's used quick fix will recognize these the way of constructing a message and setting a field. So you can see that, and if I then expand the Fixate, you'll see it's almost identical. It's exactly the same field, it's constructing a message. And then I'm now just comparing the encode and the decode of those messages. And you can see 100,000 messages, total time. So for the exact same message, I'm showing a near enough to 30% improvement. As I said earlier, this is early days. This is just a little bit of early bragging. My hope is to bring those numbers down even further. So bring this average encode. Currently, with this, we're seeing 4.4 micros. I would like to see that even lower. Now that encode and decode is somewhat artificial because it's an isolated encode and decode. So I've got another set of tests here which is more realistic, and this is actually an application which is actually processing new order single messages and processing execution reports in return. In this application, you can actually build yourself and run it in your own environment and compare the results. But in this test, which I think is more realistic, I'm seeing about a 9.8 micro latency for encode and 11.6 for decode. Now I think those numbers are all right. They're modest. Again, compared to the commercial fix engines, they're certainly not as good as I say the Onyx or the bits. But those commercial engines cost tens of thousands of dollars. This is a free open source project. So, you know, I guess one of my longer term objectives is to get some sponsorship and get some people using it and get a bit more of a community working on it so that we can improve this. And I think it is certainly within our reach. I think the model that I've chosen, which is a statically compiled model, is actually the most likely to produce the lowest latency without actually custom coding each of the fix versions directly, which is how the commercial guys do it. And you know, you need a pretty big team of people to do that.
Yeah, those are pretty good. Those are pretty good numbers. So, yeah, so compared to what's happening now with the use of FPGA, which is becoming more popular with Fix, again with the commercial guys, I know they're quoting much lower numbers than that. A couple of micros they're quoting. They keep those numbers close to their chest. But I think if you're talking about hardware and FPGA type solutions, then you're really in another realm. You know, you're talking about significant investment in your infrastructure. And I think, yeah, Fixate isn't in that space yet. I'll have a question about that at the end.
All right.
So, who's using Fixate? This is a question I get asked a lot. And the short answer is, I know of 2 institutions that are using it, but I can't name them, which is convenient for me. And makes it difficult for me to, to demonstrate a production environment. The organisation I'm currently working for is also considering using it. I actually have a full-time job. I work for a market maker, and we have a number of connections to exchanges that use Fix, and they're considering using it here as well. But as I say, I get a lot of questions about how is it being used, who's using it, and I think they're legitimate questions. If I was considering deploying Fixate, it's a new project. It's still marked as in beta. I haven't actually hit version 1 yet. Excuse me. So I guess it's the nature of being an open source project, and there's a bit of chicken and egg in this. It's hard to get established without people using it, and yet people will think, well, I'll just hold back and see who else takes it up and let them go through any pain that there might be, and then once they've established that it works, then I'll use it. So I'm sort of in that space at the moment. I get a lot of emails, questions, as I say, and they indicate an understandable conservatism. So there's no real easy answer to that. The 2 organisations that I know are using it have put in some development themselves, and I'm not aware of. I haven't seen the code that they've developed. It is an open source project. You can take the code and do what you like with it. They're not publishing it, so they can do what they like. It's a lesser GPL license. I know they've made some changes to the compiler. I know they've made some changes to the runtime library for their own purposes. That's all I know about them. They're in production. The other organisation that I know is using it is not in production with it yet, but they're just about to go into production. They're medium-sized firms. They're both HFT. They're both high-frequency guys. Their primary interest is low latency. They're not so much interested in any of the other features that Fix provides. They're really just interested in bulk, simple new orders and execution reports. They're not interested in persistence. They really have a very, very simple view. And I also had a particular interest in the use of FPGA, and one of them I know is thinking about how they could migrate Fixate to FPGA. Now, I know that's a huge job, and I really don't know much about FPGA. I know some people who do it. It's a highly specialised skill. So, in the more general open source community, I get a lot of questions from people who appear to be in development mode. So I don't know who they are, and people keep this sort of information, institutions keep this sort of information close to their chest. But judging by the number of emails and questions I get in the user group, I couldn't put a number on how many out there are using it, but it's more than a handful. So where am I going next with Fixate? Well, I just described how I have a generalized model which can take any fixed schema and produce code. Well, where I'd like to take it next is in that code generation to change the model that I currently use, which is essentially a series of static tables which describe all of the fields and messages and instruct the runtime library to encode and decode. What I'd like to do is to change that and actually generate code in much the same way as the commercial fix engines do, but generate highly optimizable code. And code that can be tweaked for maximum performance. And I guess that's where I'd like to go next, but that would require, that's a huge restructuring of Fixate. But that's my intention. And I think if I could bring the latency down, I guess the sort of El Dorado is around the 4 micros, 3 to 4 micros. If I can bring down an encode around the 3 to 4 micro space, or even lower, I think that's really in within reach of the sort of numbers that the HFT guys are looking for, without going to hardware, without going to FPGA. I guess another broader objective is to bring more people into the project. I've got 2 other guys working with me. They're committed, but they're obviously less committed than I am. It's my project. They're sort of helping out. What I'm really looking for is more participants, more developers, people who have used it or have an intention to use it and want to get involved. I think it's the sort of thing that's going to need a sort of more switched on community of people. It can't just be me. And I guess I'd like it to have a life of its own.
So you can have your own life?
So I can have my own life. And I can report that my wife has been very unhappy with Fixate. My kids haven't been very happy with it either. I've probably spent a little bit too much time at home. And, I guess I'd like to think that other people could take it up and, it's not entirely altruistic, but, mostly. So, perhaps I could just talk a little bit more about how this might work for the sort of people that are in your group, Brian.
Sure.
Now, I know a lot of people in your group are C++ developers.
Yeah.
And probably a lot more are using sort of vendor solutions to provide.
Well, we've got a mixed bag of people. Right now we use an open source trading platform called TradeLink. It's pretty well the #1 trading platform out there for open source. I've looked at a lot, like AlgoTrader, ActiveQuant, but the best one I've come across is this TradeLink. And the thing is, I use it just does everything I need it to do. You get all the source code. There's no licensing, blah 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 blah. But the problem is, it's in .NET, and trying to be able to bridge that kind of platform using Fix, because there is a need of Fix in this platform. It's just trying to find a way to bridge the two. Because if you do, then you'll open it up to about 25,000 people out there that probably are crying desperate for this sort of thing. And not only that, but if you know that TradeLink can use a Fix type of bridge or a connector, you will get a lot more people, not just through Fix8, but also for TradeLink as well. I could see huge. This is probably its only deficiency is the Fix component for the TradeLink. But it's Windows. I mean,
right. Yeah, the thing is that Fixate currently is not supported, and Windows is not supported on Fixate. And I actually have a guy who's contacted me, and he said he's interested in doing a port. So I'm not a Windows guy. I probably could do the port, but I want to stay focused on Linux.
Yeah.
So it's probably something else that someone else should take up. So this guy has offered to do it. I'm not quite sure how big a job he thinks he's letting himself in on there. It is a big job. There is a compromise solution, which is Cygwin.
Yeah, we talked about that.
Yeah.
But the problem is, what?
I haven't actually tried to compile it to Cygwin. I think it should be okay. But yes, there is a problem of how to get your trade link to somehow wrapper the Cygwin executable. I'm not quite sure how you do that.
Yeah, well, I just put out a question to everybody if anyone's interested in helping David out. If anyone wants to type away in the chat, let me know, and we can go from there. Anybody with C experience or C++ experience can help out David accomplishing a Windows port. It's a big job, apparently.
It's a big job.
Andrew's got a question about how many lines of source code. Actually, let me bring in Andrew. He's a really good C++ guy. He may be able to provide some input. I'm gonna unblock you, Andrew. Yeah. Andrew, you out there?
Yeah. Now, the last time you did this, about 15 minutes ago, all of a sudden I lost all contact.
Yeah, all we got was just a bzzz. But go ahead. I feel like I'm a radio announcer. Go ahead.
What I was going to say before was that Berkeley DB was purchased by Oracle, and they now charge for it. So there's a couple of those mapping kind of databases that are free. One's called, I think it's called Tokyo, and another one has got some eastern town name. I forget what it's called, but if you look up, if you Google NoSQL databases, you can find them. Anyway, go ahead.
So I was going to say, in version 0.7 of Fixate, I've removed the dependency on Berkeley.
You said that last time and I lost the connection. Yeah. Okay, so currently you support what? 32-bit Linux, 64-bit, or
64-bit, 32-bit, yeah, both.
Okay. What makes it dependent on Linux?
Or Windows.
I would
it's
have
not so much. Yeah, no, good question. It's not so much dependent on it. There's no. I mean, it uses, standard POSIX calls.
Right.
There's nothing specifically Linux in it. It's just it hasn't been ported to any other platform. I think that it's really, when we're talking about Windows, it's really more about the fact that those build environments really are quite different. I think the code should port okay. There's nothing specifically Linux in it.
Yeah.
It's really just. Sorry.
I was going to say it'd be mainly I/O and computational. So you should. I mean, basically, it should be a console type app and relatively straightforward.
Yeah, that's right. That's right. Yeah. I mean, that's right. I think it's initially a big job, particularly the getting the build to work. The make system is quite different. But yeah, I think once you achieve that, jump that hurdle, then yeah, I think the bulk of the code would compile pretty comfortably, I would imagine.
How many lines is it roughly, David?
If we're talking about the runtime library, I think it's about 20,000. But if you include the generated code, which if you're looking at total lines in any individual application, then it would probably be something like 120,000.
So when you say generated code,
yeah.
Do you mean that it's generating XML or what?
It's generating C++ code. So the Fixate compiler, you run that over your XML schema, and it generates a whole lot of code, which you then incorporate into your application.
So you actually don't generate Fix XML. You actually generate.
No.
You actually take that as an input and generate.
That's right.
C++ code. The objective being what? To speed it up?
Yes. The two things. Firstly, to speed it up, but secondly, to provide you complete control over the fix that's spoken.
Yeah, this diagram must have come up during my downtime. I get you now.
Oh, okay. Yeah. For example, a lot of the HFT guys have a very highly tuned, optimized fix that they want to speak, and they want to weed out anything that they don't use. So you could prune down your schema here and just generate the minimum set of messages and the minimum set of fields that you're going to use. That then is then incorporated into your code, compiler application linked with the runtime library. So when we're talking about speed, the other thing, of course, is that this code then can be optimized by your compiler or even by yourself.
Yeah. Will it generate 64-bit code or bit neutral code?
Well, it just generates standard C++ code. It's largely platform independent. So the integral data sizes, the integral data types are default. So int, unsigned, etc. I don't use uint32 or uint64 and like that in the generated code. So it should port across to both architectures, 32-bit, 64-bit.
Okay. And internally, when you say it's an open source project, is the compiler itself an open source project?
Yes. The whole thing
so is the compiler the code generator separated from the parser, so that in principle you wouldn't have to generate C++, you could generate assembly for
No, at the moment it only generates C++.
Right, but I'm saying, is it written in a modular or layered fashion, so that essentially you could take out one layer and interface to the higher level of the compiler?
Oh, I see. No, it doesn't. No, it doesn't. It doesn't have a back end, if that's what you mean. No.
Right.
Yeah.
Okay.
It's a code generator more than a compiler in that respect. Yeah. No. Fair enough.
I see.
That'd be nice to have that.
Yeah, because I would think that you should take this out of open source and make it proprietary, and then design it like that, because you can make a lot of money selling this to people who want to generate code to run on particular GPUs.
Platform. So you should take the compiler out, but leave the runtime library as it is.
Yeah.
That's not a bad idea. That's an interesting idea. Thing is, I'm not really a compiler writer. I mean, I've probably got as much experience and knowledge about writing compilers as the next person, which is not very much. Apart from what I remember from computer science days. That's a very specialised field.
Right.
But I guess if you abstract the back end, if you generated some sort of intermediate code, then people could write their own back ends.
Yeah.
Much like GCC or modern compilers work.
Just like the Java runtimes become the sort of platform of choice for so many different languages now.
Right. So I could generate some sort of opcodes. Yeah, that's an interesting idea.
Okay. There are my questions, Brian. It's a very interesting project.
Yeah, I think I've got some ideas as well. I mean, just for you, David, I know that like with World of MATLAB, there's like 5 different things you could do at once with MATLAB. But one of the things that if you should be part of, actually I might put up a video, I don't know yet, but what I'm doing is I have the capability of taking a MATLAB, like a visual model in Simulink, which is part of MATLAB, and then from there I can generate code for either C or C++. So I'm thinking is one of the big areas that's lacking with this type of model of development is to be able to bring in something like a fixed component and be able to bridge the two for the, you have an API into the fix and then have the model interface with the fix. So, and then all you need is just the data component that will do the real-time data capture. But it's just something I was also thinking as well. But this might be down the road right now. But it's just another idea that you could look at to bridge these types of models coming out of Simulink with C++ or C and then somehow tie it into the Fixate.
Right.
It'd be an awesome way to generate a basic primitive trading platform for high frequency trading. But it's just a matter of how do you tie the two in together. Now, with your code, how does it work? Is it sort of like an API equivalent, or like I'm just trying to...
The generated code or the runtime?
Yeah, your generated code.
The generated code is what the generated code looks like is actually probably a good way to do it is just pull this up here. It actually generates classes, C++ classes, which you then use in your application. It also generates static data and metadata, which the runtime library uses to encode and decode. So it actually generates a lot of different code used in different parts of your application. Okay. If I just give you an example, if I go over to classes, I'll show you some of the generated code.
Well, I guess another quick question is, let's say if I have a system that I want to develop, but have different fixed configurations for different exchanges, would that mean I have to generate a separate set of code for each exchange? Does that make sense?
Yes, but the compiler does that for you.
Okay.
Yeah, and what you can have an application that has a number of different fixed variants that it speaks. So you could have an application which spoke to a number of different exchanges. Each of those exchanges spoke a different fixed variant, and each of those variants were independently generated by the compiler.
Okay.
And they would happily all coexist in one application because it's all strictly namespaced.
So if you do it that way, would you have a lot of duplicate code as well, like a lot of redundant code?
You would have a lot of duplicate code, but I don't think there's any penalty with that because it's generated code, and it's presented as a .si or a shared object.
Okay.
I don't think if the code is not touched, most operating systems will swap it out. It's not used.
Okay.
It might take up a lot of space if you load the whole thing, but
yeah.
I think memory footprint of these things is not that critical.
Okay.
I just wanted to show I'm having trouble finding this example now, but
this is just for the group. If anyone's got any questions that anybody wants to type out in the chat, I'm sure David can easily answer them, or I can unmute you guys, whoever, just type away so I know that you've got a burning question.
Okay, just bear with me a second while
No problem, no problem.
Find this here. Here's a new order single. Okay, so this is an example of compiler generated code.
Okay.
Now you see here, I'm highlighting this here, text. Can you see that?
Yeah.
That's a namespace. That's like a namespace that I created just for the purposes of
so that could be an exchange of some kind, right?
Yeah, it's an example exchange.
Okay.
So you can have, because this is all neatly ordered within namespaces, you can support multiple fixed variants in one application.
Okay.
And so within this, this is all been generated by the compiler. And this code here, you would basically use it in much the same way as you use the quick fix if you use quick fix classes. So each message is basically encapsulated within a class. So
okay.
Your single is a class.
So do you have anything that's predefined for, let's say, the CME or for any other exchange?
No, I don't. But if you've got the schema,
yeah,
it's all done.
I mean, just from a revenue point of view, that would be probably a good way for you to generate some coin for yourself if you're putting them out as time into it. You could
well,
sell.
That's assuming that they're in the public domain. Are they in the public domain? I'm not sure if they are.
Well, I know of another project where there was source code available. Let me just see if I can find it. I know that there was a guy who did put together a subset of code specific infix for each individual exchange. I'm not sure if, I don't think that's even online anymore. But I'll see what I can dig up for you. Does anybody else got any questions for David? Andrew? Wow, everyone's all quiet tonight. Oh, we got a question from John. I don't know if you can see that. I understand that fix is dependent upon TBB, unlike quick fix. I'm just reading out so that when I record it, which is Intel architecture specific. Do you plan on porting fixed to ARM? 64-bit ARM servers are slated to be coming out soon. So,
okay, good question. I have no immediate plans, but I guess the dependence on TBB does present a bit of a problem there. I'm assuming that the ARM processor supports compare and swap, which is the main instruction primitive that TBB uses. And if it does, then it shouldn't be that big a job to support the lock-free containers and other functions supplied by TBB. Now, there are, for example, ports of TBB to Spark. So I guess when it happens, I'd look at it. I think it is possible, or should be possible, and maybe this is something that I'll look at, to remove the dependence on TBB and perhaps provide some more generic way of plugging in lock-free containers. But at the moment, there isn't. But yes, that's a good question.
I'm just typing out one called FastFlow. It is a threading API. It's open source as well. It's supposed to be performant or
FastFlow. I've actually heard of that one. Yeah.
Yeah. Apparently, it's very fast.
Is it platform independent?
Yeah, it is, and processor independent as well.
This browser's chosen Bing.
Apparently, it's very fast. You might have to do fast flow threading. Yeah, fast flow programming multi-cores, designed by an Italian. I did check into it last fall. I quite like the looks of it. Anybody else got any questions for David? Okay, John's got another question for you. What makes proprietary fix engines like Onyx so much faster than Fix or Quick Fix?
Okay, the answer to that question is resources. What these guys do is they take a particular fixed variant, particular fixed version, let's just say CME Fix 4.2, and they go through all the messages and they handcraft those messages, the encode and decode. So then they performance test and fine tune, and so they can get the very, very best performance. But that takes a lot of work, you know, and that's why they cost a lot of money. They basically handcraft the messages. That's what makes them faster. But you know, they're commercial offerings that you pay for that. If you've got budget and you can afford it, then the commercial ones are certainly great, no question. If you're on a limited budget, or you've allocated your budget to something else, then you use the open source ones. As I said, I'd like to sort of try and bridge that gap by being sort of clever about it and not relying on hand coding messages. But that's how they do it. Yeah.
I just thought of something else, but it just slipped my mind.
Well, I mean, to be honest, I talked to a couple of quants in the UK, and they tell me they're spending up to $10,000 a month on a month, not once, a month, on their FIX protocols and or their FIX engines. And not only that, but the exchanges are always changing their configuration as well.
That's right. That's right. That's another problem. That's right. So again, I think with Fixate, we can deal with all that. What we can't do, what we can't match, is the very, very high performance that they can offer on particular messages. This is a particularly new order, single, and execution reports. They're highly optimized, as I said, because they're hand coded, largely hand coded. Of course, you never get to see that code.
Dude. Yeah. It's a black box.
Black box. But yeah, that's the reason. It's interesting that they also try and compare themselves to QuickFix. I know. I think it's Onyx, or one of the vendors. Might be B2Bits. They actually have a comparison on their website. I think it's Fix Antenna versus QuickFix. But I think the comparison is unfair. As I say, you know, QuickFix is an open source offering, and it doesn't have the same sort of resources that have been thrown at it to produce something like Fix Antenna. It's also worth noting that I think QuickFix, probably accounts for, I would guess, 80% of the Linux Fix implementations out there are using QuickFix. So many of the big banks, institutions are all using QuickFix. I won't mention their names, but I know from my own experience. And you know, QuickFix has been around for many, many years. A good 13 years, I think. So, yeah, they've got a huge user base.
Not only that, but there's a Java port, there's a Windows port.
Yeah, there's a .NET, there's a C#, there's QuickFix N, QuickFix J. Yeah, it's all. It's had a long life, and it's been a lot of development. But it also has to be said that it's a project that hasn't, at least in C++, it hasn't had much development at all in the last 10 years. I think they went from version 1.12, which was 2003, I think 2002, and they released 1.13 last year or the year before, and that's it. So there's not been much work on it. I think what's happened is because of the sort of license that it's offered under, what a lot of institutions have done, and banks in particular, have basically taken the QuickFix code and imported it into their repositories, source repositories, and basically modified it and continued to modify it internally.
Yeah.
Basically taken that code as their own. So, it'd be very hard for the QuickFix people to influence what's happening with that code now. Once you've branched and you're that far away from the main line, it's very hard to incorporate bug fixes and changes. That's the sort of penalty of incorporating the code yourself. If you've got people to fix problems yourself, of course you can do that. But the more you depart from the main tree, the harder it gets to bring bug fixes and improvements that are happening in the main line.
John's got another question. He's asking if you're going to implement the fast fix protocol.
No, I'm not going to do fast fix. The fast fix encoders and decoders, the very best are proprietary. There are reference encoders and decoders out there. I think Fixate can't really offer much in the fast fix world. I think fast fix is really very specific to market data, streaming market data, and
as I say, the reference encoders are, they're not very, they're average, but the very best encoders are all proprietary. And that in itself is a whole different world. Now, a couple of the guys at Cantor Engineering in Sweden, I think Rolf, he actually developed the FAST protocol, I believe. And it's a great idea, and it works very, very well. But it's very proprietary. I think that's best left to especially the sell-side institutions, exchanges and stuff to optimize. I don't think there's a lot of room in there for Fixate. The other thing is that in the streaming market data world, you've got each making big inroads on FAST. And my feeling is that FAST might be nearing the end of its sort of popular phase. I don't know if that's just my prediction. I think from what I'm seeing in the industry, each is making huge inroads in that space. But time will tell.
Rama's got a question. Where are the markets? For example, IBEX, Madrid, and Frankfurt. I'm not sure what he means by that. I can bring him online to see if he wants to be part of it, to ask this question. I'm just going to unblock him. Hello, Rama. If you can speak. You out there, Rama? You want to be a little more specific with the question? I guess I can't hear him. Maybe his headset's not working. You out there, Rama? No. Okay, we got another question from John again. Yeah, here. I don't know if you can read it. Considering what happened to Quick Fix, have you considered LPGL instead of BSD? I guess the licensing.
If I consider BSD instead of LGPL. Is that what you're saying?
Yeah, considering what happened to Quick Fix, have you considered LGPL instead of BSD, the licensing?
Yeah, no, it is LGPL. It is LGPL. Quick Fix is BSD.
Okay, let me just get Rama. Rama, if you want to re-enter your question, or let me know if you can handle text or audio, sorry. John, if you got another question. I mean, I could go on and on asking them a bunch of questions, but I don't want to take up too much of your time or the group's time or whatnot. In terms of FPGA, what do you know of? Like, you've never looked at FPGA whatsoever?
I have, but I've never developed on it. I mean, I've seen where I'm working now. There's an FPGA initiative underway, but the people that work on it, it's a sort of argot. They speak this sort of different language. It's a highly specialised domain and requires a lot of work to get up to speed on it. And it's not just a question of taking code and bringing it over and recompiling it or whatever. There's a whole engineering process that goes into making code FPGA portable. And in fact, you have to make a lot of compromises, take a lot of compromises in order to make the code work. And sometimes code just will not work. Now, there is actually, for example, a couple of companies out there that have taken Quick Fix, but only certain aspects of Quick Fix, and moved them onto FPGA. But there's no generalized port FPGA. It's very bespoke.
Well, the question I ask is always because, how do you stream the fix into an FPGA board? That's what I'm trying to understand is, in Simulink you can generate the code from the model, but how do you handle all the streaming as the data comes in? And I know it's traditionally in Fix protocol. That's what I'm trying to understand. So,
yeah, I'm really out of my depth on that.
Okay.
I mean, I understand in principle.
Okay, not a problem.
I haven't actually implemented it myself. Although, I think, from what I've been told, it is possible to do it, but there are a lot of compromises that have been made with code, and a lot of changes structurally that have been made in order to make it FPGA-able, if you like.
Yeah, it's not as easy. Rama came back. I think what he was referring to for the markets like Madrid and Frankfurt, he wanted to know what kind of protocol are used for those markets. Do you know by chance? The protocols for Madrid and Frankfurt.
No, I don't know. No, I have no information on that.
I think he's asking IBEX. I think you should be able to find that on their website. They have ways, developers section on each of those exchanges.
Usually, yeah.
John's got a question. Does Fixate support market data requests?
Absolutely. Well, it's in the if it's in the Fix schema, then Fixate will generate the relevant code. Obviously, you have to still implement it. Probably a good example. Actually, that's probably a good question, and that would lead into just having a look at an example. What Fixate doesn't do is provide implementations on how you would handle those messages, so market data requests, for example. But it provides a framework for you to implement that yourself. So if you look at, let me just pull up this example here. Okay. Is this visible, Brian?
Sort of. Again, you might want to. Actually, it should be okay. I can kind of see it.
How's that?
But yeah, it's fine. Yeah, it should be fine.
Okay, so just let me scroll down here. So see this call here. So this is an example of the code that you would write to handle a callback from the runtime library. So when a message has been received, a new order single has been received, this method is called. So in the case of a market data receipt or broadcast, this is the hook into your application to handle it. The actual implementation is up to you. What you do with that is actually in user space, in user land. Much the same way as Quick Fix does it. You're still required to implement what you do with those messages. It doesn't provide business layer.
Yeah. Anybody got any other questions?
Does that answer the question?
I think so. Actually, you know what? Oh, you know what, John? I'm gonna unblock you. Can you? I'm not sure if John can speak. He's got a lot of questions, so why don't we just bring him in audio? Hey, John, you up there? John? Can you hear me? Okay? Can you hear me? Okay? I guess. No, I don't think. Hang on, John. I'm going to block you. John's got another question, though. Where is it? You're using IE7 on Wine right now. What Linux distribution do you recommend for Fixate?
Any. Really, doesn't matter. It'll run. I've tested it and run it on CentOS, Red Hat, Debian, Ubuntu, Scientific. Yeah, it doesn't matter. As long as it's a modern distro, it'll work.
What do most institutions use?
Probably Red Hat Enterprise Linux, SUSE, and CentOS are probably the most widely used.
Okay.
For example, a lot of the European banks tend to use SUSE.
Okay.
Or Debian, mostly SUSE. More American institutions tend to use Red Hat.
Yeah, it's for a commercial purpose.
CentOS, you've got Fedora. They all, all the modern distros, it'll run fine.
Okay.
There's no distro specifics in it. I do also, as of a few weeks ago, I also release RPMs, and I'm also going to start releasing .debs. So, but it'll work on pretty well any Linux distribution.
Yeah, Rama's commenting that Susie's good. Susie real time is nice.
Yeah.
So I'm running that fine.
As
long as it's on Intel.
Anybody else got any questions for David? Like I said, I could hold you up forever and ever, David. I don't want to do that to you. John's got another question. What's your preferred IDE? Eclipse? NetBeans?
No, whatever you want to use, it's fine. You know, I don't even use IDEs anymore. I use Vim.
Oh, you're old school.
I'm very old school.
You have a make file, or you just compile them?
Yeah.
Hope we're not drawing straws here.
I guess what I really like to say is I'm really interested in feedback. If anybody uses it, starts to use it, if you prefer not to sort of go public and go into the support group, if you want to email me directly with any questions or problems, I'm quite happy to take the questions. As long as you make it clear that you have a particular reason for not wanting to go public. Because what I found is I get asked a lot of questions individually, and I have to answer the same question over and over and over again.
Yeah.
So what I'll often do when I get those emails, I say, could you please repost this to the support group? And often the people go silent. I don't hear anything else. I don't want to discourage the questions. So if you do want to ask questions, you want some help, but you don't want to have your question posted in the support group, then just email me and say, look, I'd rather I didn't have this conversation broadcast. And I'll understand and I'll try and help you out. I really want to encourage use, obviously, and the more people that use it, the better that we can make it. And from a stability standpoint, I want to move it to a stable production release, and I need more people to use it. So I sort of need some help.
Yeah.
So I really want to encourage people to give it a go.
I mean, I know what you're saying about finding people and reposting people's questions, but I try to keep I post the question, but not their identity, or I try to make it more general so that I don't have to. And I know what you're saying about looking or having people who use your platform or your project. I understand that, but they don't want to be exposed that they're using it. I have the same thing with my membership as well. So I can.
That's right. They're quite happy to glean ideas and experience from others.
Yeah.
But they want to do it honestly. I understand that, and then particularly in the HFT world.
Well, it's very secretive, very it's a whole mixed bag. I mean, I get a lot of people asking questions and offering ideas, but there's so much that's how I learn. But I wish I could put it out there in the public domain, but I can't. So it's just one of those things I don't have the privilege to do, but I do what I can to get people so people can learn about HFT and that sort of thing. But to be honest, I mean, it's good that there's a really alternative open source fix solution out there, because I mean, hats off to you, man. It's a lot of work, and
thank you.
I'm glad your wife is able to help, hopefully tolerate it. I've been through that before. I know the feeling. John's got another question. Is GCC or CLang or ICC the best compiler for Fixate?
I think GCC is better. If you look at that, I actually do a comparison there in the performance. If you go to the site and have a look, you'll see I go into some detail here, but in summary, you can see here that in my testing on my platform, GCC outperforms CLang. There's probably a degree of margin of error in there. They're probably very similar. The way I'm using CLang is I'm using the GCC backend on it anyway. Look, I haven't tried it on the Intel compiler. Who knows? If someone would be interested in giving that a go, I'd really like to see the results of that. Because Intel do brag about the performance of their compiler on their platforms. And, you know, I'm not going to knock it. It does look pretty good.
Isn't that compiler commercial as well, though?
Yeah, it is commercial compiler.
Yeah.
But there is a community version.
Yeah.
You've got to sign up and get a community license. But yeah, it's not open source, but it's a community version.
Okay.
A non-commercial version.
Yeah.
Much like TBB. TBB is a non-commercial version of that.
Right. But I would think that GCC is the standard C compilers out there, right?
Pretty well.
Yeah.
Pretty well.
Anybody else?
You know, I mean, any C++ compiler should work. The compiler generates standard C++, you know, C++ 03, and the runtime library is standard C++ / POSIX compliant.
Yeah.
And the only reason I already compiled it on the C-Lang was really to just have another compiler over the code. And it was amazing how many discrepancies and, I wouldn't say errors, but how noisy the compiler was, the C-Lang compiler was. It's a much stricter, it's a more pedantic compiler than GCC, which is great, because it actually uncovered things which I could tidy up. And I thought, well, since I got it running under the C-Lang, I may as well present the performance that I measured and also how to do it. It's very easy to do.
Anybody else got any questions at all? Anybody? Going once, twice? We had up to 14 people, just so you know. It's not bad, actually. Anybody else got any questions? Going once, twice, 3 times, and then all of a sudden, once, twice. Actually, that might be it. You know what I'm going to try and do? I'm going to try. I built the Fixate in Linux. I'm going to try to take an attempt to see if I can do it in the Visual C Studio environment and see what happens.
Good luck.
I appreciate that.
Well, have you tried the Sigwin, or have you thought about that? Is that what you say?
The thing is, I have to keep it all in the world of .NET. That's the thing. Like, I haven't tried Sigwin. I'm sure it should work. Do you have users that actually have successfully built with Sigwin?
I haven't heard. If there are, I'm unaware of it. But yeah, I should probably try it myself.
Because John's asking about Ming W. Ooh.
Well, that's another one. Yeah, another one.
No, I just stick with Sigwin. Thank you.
Yeah.
Sorry, John. I'm just not a fan. I've tried Ming W.
Most of the people in your group tend to be more on the Windows side? Or
It's a whole mix match. It's like last summer it was all Linux, and then the problem I had with Linux is that I'm trying to build something and then I have to build something else, and that needs to be built because there's all these dependencies that need to be built. And then when you move it into another OS, it's like, that doesn't work. It's like, you know, there's just no set of standards. And I was able to get FastFlow built, but then I couldn't build it on something else, and you know what I mean? It just got too much. But I'll give it a whirl on Windows, because once you get it on Windows, I'm for sure that's going to open up a whole new world for you. But yeah, check out FastFlow.
Does FastFlow implement disruptor pattern?
I think so, but last time I checked, it was quite fast for threading.
Yeah, it's really really the reason I use TBB is I want a lock-free container.
Yeah.
So it doesn't use any mutexes. It uses compare and swap instruction.
Yeah, I think
that's really what I use it for. But if I could find some library that provided that capability in a more platform-independent way, I would happily remove that dependence on TBB.
Yeah, I think FastFlow works that way. I can't remember exactly. I think there was there was a Windows port as well. Last time I checked.
Well, TVB is supported on Windows, by the way.
Yeah, I mean, is the TVB
really Intel.
Linux only, or?
No, it's Intel. It's just Intel. So there's TVB on Windows.
Oh, okay.
Yeah. It's really the hard. It's because of the, as I say, the CPU instruction, the compare and swap CPU instructions that it is.
What other libraries other dependencies does the project have, like TVB?
Well, there was, as I say, the dependency on Berkeley DB has now been lifted because I'm releasing this weekend version 0.7.0, and that uses file-based persistence by default.
Okay.
Indexed file-based persistence. You can still use Berkeley DB if you want to, but you're not required to anymore.
Okay.
So the only dependence now is Poco Development Library, and TVB.
Okay.
TVB. Poco is supported across multiple platforms.
Okay.
So there shouldn't be a problem with Poco. TVB, there is that constraint on Intel at the moment, AMD Intel.
Okay, John brought
yes.
John brought up an interesting question about logging. What databases for Fixate support for logging?
At the moment, it's just logging to flat files. It also will log to a pipe, or it will do a UDP broadcast log. It's really up to you to hook into that and develop your own log. There is a generic logging interface which you can extend to provide your own specialized logging. The logging is asynchronous and it's off the critical path. So you can basically take those log messages off the critical path and do what you like with them. Log them as efficiently as you like. The idea is to get them off the critical path. So again, I currently use lock-free queues to do that. And also provide other ways of getting the messages out. As I say, you can log them to a file, you can broadcast them, UDP broadcast, you can send them to a pipe, Unix pipe. But it's very, very flexible. The persistence component is also abstracted. There's a base persistence class which you could extend to provide any persistence model that you chose. So it's sort of written in that respect, it's written in a proper OO paradigm. That although it does have these dependencies on, for example, up until now, the dependency on Berkeley DB, that was only because I hadn't implemented any other persistor, and with the exception of a memory persistor. And obviously for Fix, you must have a persistor. There is the whole request retransmission metaphor, which is a requirement of Fix. So I had to provide a reference implementation of a proper disk-based persistence, and that's why I chose Berkeley. But I got a lot of people saying, we don't want to use Berkeley. Why is Berkeley there? Couldn't we do the same thing that QuickFix does with just a flat file? So, I've listened to those complaints, and they're legitimate complaints, and I've now removed that dependence.
John's got another question. Any ports to Java or Python with Swig?
Yeah, again, I'm sort of out of my depth on that. That's really, if someone else would like to do that, that'd be great.
This is a time thing.
It's just a time thing, and I'm not a Java guy. I think it would be possible. Yeah, but out of my scope.
I hear you.
I'm only one guy.
Yeah. Anybody else got any questions at all? To the group, to myself, to David? Otherwise, we'll wrap it up.
Okay.
Yeah, because it's quite late for you, isn't it?
Yeah, good. Oh, it's not late. It's late for you more than me.
Yeah, that's no big deal. I'm used to this. I have no wife anymore, so.
Oh, sorry.
Sacrifices. Oop.
Are Are you a computer widower?
Yeah, I guess so. Sure, why not? I'll take that. John asks, why C++ versus C? I mean, that's a pretty given question, I think. Object-oriented, class, hierarchy, all that.
But you know what? If I'd written it in C, it probably would be faster. Certain aspects of it would be faster, but it'd be a nightmare to maintain it.
Yeah.
It really would be. And there'd be huge amounts of repetition. In fact, if you wrote it in C, you would try and write it in a sort of object-oriented manner, because otherwise you would have so much duplication of code.
Yeah.
Anyway, these days, modern compilers, C++ is pretty well as performant as C these days. I mean, long gone are the days where you had a C front and you had a C++ pre-compiler, if you like. Modern compilers natively compile C++, and the performance that they get is pretty close to C. C is still dominant in the embedded world, probably because it's compact.
Yeah.
Fast but compact, and makes the minimal assumptions about what it's running on. And also has a much smaller runtime library, the libc, for example. The embedded runtime libraries can be pruned and made very, very lightweight. So I think that's why it's still very popular in the embedded world. But I think in bigger application spaces, C++ is... It's interesting because if anyone's had a look at the TIOBE website, if you've ever seen TIOBE, T-I-O-B-E, which monthly produces a report on language popularity, it's quite a respected site. C++ is making a bit of a comeback. After being on a downward slope for some years, it's making a comeback with Objective-C, obviously.
Yeah, I was going to say, because of iPhone.
Because of iPhone, that's right. But C# is on the decline, according to TIOBE.
Yeah.
Java's still number 1 or number 2. C++ is number 3, and maintaining it and increasing, which is an interesting development, given that all of the naysayers were saying that C++ was, is an old language and is, soon to be made, out of date and not a language you would choose for a new project. I think that's untrue.
It's a powerful language.
Yeah, I mean, there's a lot of legitimate criticisms about it. It is a difficult language to learn. There's no question. I think, and it's not being taught in institutions. They're teaching Java and functional languages.
Yeah.
And functional languages are great, but C++ is not being taught to undergraduates. At least not in Australia. I don't think in the US either.
Yeah. It's mostly Java, and Python's coming up too now.
Yeah, well, Python really, Python's sort of trying to bridge the script language divide. I think it does a nice job. Python is a great language.
Yeah.
But it's still more, it has that benefit of having one foot in the interpretive script world and another foot in the compiled language world.
Yeah.
I think it does that very well. Whereas I think compared to, say, PHP or Perl, Python, I think, is superior in that respect.
John,
I use Python a lot.
John had a question. Well, okay, first there was a comment from Rama saying he's wanting to connect with these projects to MEEF in Madrid. And also, John had a question about limitations with Quick Fix or versus Quick Fix. Besides, Fixate doesn't have database support for logging, and he's asking about stability.
Okay. With respect to the logging, I think I answered that. I think the logging functionality that Fixate provides is, in my mind, at least equivalent, if not better than Quick Fix. Now, perhaps that's a big claim, but the logging in Quick Fix is nothing special. It works, it's reliable, but it's nothing special. I think Fixate does improve on that, as I say, and it does allow you to replace it with your own. What was the other question?
Stability.
Stability, yeah, right, stability. I mean, that's a good question. And look, the main areas where Fixate needs work is in the session layer. Fixate is stable, but it hasn't quite got the critical mass of users out there to really flesh out problems, and those problems will be in the session layer. The fixed session semantics are notoriously complex and arcane. And anybody who's worked on a fixed engine will tell you, you tend to spend the bulk of your time on things like retransmission, sequence reset, all this sort of stuff. It's incredibly tedious. One of the big mistakes that they made when they designed the fixed protocol was that every message is sequenced, including heartbeats, which is a real problem. Session level messages are all heartbeated as well. So, it makes for a lot of problems. Semantic, message semantics, transactional semantics, if you like, with respect to request response. Having said all that, I still think that Fixate is stable. I believe it's stable enough for production, but I'm not prepared to put that in writing because I need that to be established by other users. It can't just be me saying I think it's production ready. I think that would be arrogant.
Yeah.
And I'm not prepared to do that. That's why I'm still marking it as beta. But in the sites that I know that are using it, I mentioned those earlier, it's been very stable. Again, as I say, it needs other people to verify that and needs to be done in a scientific manner, and I'm being completely transparent about that. In my view, it's stable. In my view, it's production worthy. But until I get more of a critical mass of people using it, establishing that, I'm still marking it as beta. To be honest.
I'm just putting a bunch of comments from people that are accidentally coming to me instead of the group. Rama said that, it's fantastic, great job. Thank you very much for making it open source.
Pleasure. Thank you for that. Thank you for that.
I think the group should be giving guys like you a lot of credit. So type away, guys.
Boy, feedback will be the most helpful. Technical feedback, questions, problems, they're the most helpful thing.
Okay.
I mean, of course, I appreciate the compliments, and what would really help the project is sort of people getting their hands dirty and finding some problems.
Yeah.
And if you're really interested, participating at whatever level you can in the project would be great. And even if that means, look, I'll tell you what I'm really looking for, Brian, which would be really great, is if someone could review it.
Don't look at me. I mean,
I'd like an independent review. Basically, getting people to use it is really about credibility. It's a credibility game.
Yeah.
And as I mentioned earlier, it's sort of chicken and egg. Yeah. So, what would be really, really helpful is some reviews. Even if it's a couple of paragraphs, I don't care. That would be great.
I could probably help you out in there. I could probably bring in somebody who's really the best guy on the planet. I mean, no offense or anything, but he's awesome. Like,
present company accepted.
He's beyond amazing. I could have him look at the whole thing if he pending time. And then maybe do a Skype session with him and stuff, one-on-one, if you want.
That'd be great. Really reviewing. That's probably the most helpful thing.
He knows his stuff. That's why that's why it became like all of a sudden the C# god, because what he showed me that C# could do, it's wow. All I could say. A couple more questions. Is Fixate multi-threaded, clustering, scaling limitations?
Definitely multi-threaded. Scaling-wise, it doesn't. It's not. It doesn't provide the scaling engine capabilities of some of the commercial offerings. It's not a complete fixed solution. It's a fixed engine.
which you would use as a component in an entire fixed solution. So, for example, it could be used in an onboarding sort of environment, but you would need to provide your own management of that. It doesn't provide a complete managed solution. It's a fix engine. But in terms of scaling, yeah, it should scale. It's really up to how you use it. It's really a component rather than a complete solution, I think is the answer to that question. Much as Quick Fix is. It's not a complete fix solution. It's a component.
Yeah. Ram, I also wanted just to say a lot of hard work he sees. I know him. He's not a tech guy, but he recognizes a lot of hard work that you've been put into it, or that you have put into it.
Yeah, it's
3 years.
You know, it's really annoying. What I find really frustrating is I spent many months chipping away at it, and often I go back and look at that code, and it takes me a good 20 minutes to work out what the hell I did. It's very frustrating because there's a lot of work that goes into these sort of things, and you can't keep all those things in your head. Anybody who's been a developer will, you probably know this yourself, Brian. So one of the things that I did middle of last year was go and fully document all the code, and that's how. If you saw that API documentation, all of this API documentation is all generated. All of this stuff is all generated using Doxygen.
Yeah.
It's all generated from the source code. So you can generate all this yourself and look at it offline.
Yeah.
That's a bit of an aside, but I often find myself looking at this to refresh my memory of how things are.
Yeah. John was asking about latency in milliseconds. I think he's already covered that, John. In the you want to take it? He was just asking about your metrics on latency. Understand Onyx.
I'll be quoting microseconds.
Yeah.
Micros, not millis.
Oh, I'm sorry, Microsoft.
It's about 3 orders of magnitude there, right?
Yeah, sorry. I should be slapped on
That's
that.
right. So what was the question?
What is the latency in microseconds? I understand Onyx S is 7 microseconds.
Yep. Did you have a number to compare to?
Well, I'm not sure if he's talking about the complete turnaround time of execution, but it just says Onyx S is 7 seconds. If you want to specify even more, John?
7 micros.
7 microseconds.
For?
I'm understanding it as a turnaround time for execution. Let me just unblock him again. Let me try this again. I'm going to unblock you, John. John, you out there? John, you out there? John? John? Oh? He says doesn't want to speak. Okay, just muted him. Let's just see. Oh, it says his mic's not working. He put a link up. I don't know if you can see it in the footnotes or in info notes.
Right. Onyx, yep.
Let's see, packets per second.
10 micros per execution report. Two micros. Cell latency, bar latency. I'm not quite sure I understand that, but
yeah.
It says, okay, this is a distribution of, so they're all around the 10 micros.
But are you pretty well in line with?
No, I'm not in line with those. No, no, that's better than Fixate.
Right, but unless
as I explained earlier, there's a reason for that. Now, the latencies that I'm quoting in Fixate, I only quote the encode and the decode. I'm not quite sure what we're looking at here, because if you're talking about, if you're measuring turnaround, then that must also include some of the business code. I'm not quite sure. I probably need to read it more closely to see what they're quoting. But typically with these things, you would measure the time it took from wire to application, or from application to wire. You wouldn't include network latency, obviously. You're just looking at encoded, and typically the bulk of that is encoding and decoding through the framework. So if they're quoting 6.9 micros for an execution report, my guess is the bulk of that is encoding it or decoding it.
Okay.
So Fixate's quoting about 11 micros.
That's nothing. Compared, you're spending up to $3,000 a month on this engine.
Yeah. And, I mean, I probably need to qualify that comment. I'm not quite sure exactly what else they're doing in that. It could be they may have optimized the network stack so that when you're actually on the wire, getting to the wire is actually much faster than if you.
Plus, you got to factor in the hardware as well. If it's Apple
and hardware as well. Exactly. If you look at the hardware that I quote, it's very pedestrian. I'm just using this is basically a Mac Mini. Right?
Right.
This is not production sort of standard hardware. This is a Mac Mini in my cupboard at home. Right? So I haven't tested it on proper production hardware. I'd like to do that. In fact, if someone would like to offer me a login or someone would like to offer to do this test on production, modern production hardware, that'd be great. So I think we'd see these numbers here. Sorry, these numbers here come down substantially.
For open source, that's pretty impressive. It's on its own.
So I think the reason, my explanation for that is because it's all statically generated code. I think when a message is encoded or decoded, there is the minimum amount of processing in the actual message and field, at the message and field level. It's using very fast lookup tables with static data. I think a lot of that data stays in the L2 cache. So I think cache coherency is preserved, has a greater chance of being preserved if you're talking about chunks of data. I think that's where the optimization, that's where the performance is coming from. But I do think we can do a lot better than that.
From my understanding, with what I understand, like again, I'm not a low-level whack-em-in-the-weeds kind of developer. From my understanding, if you keep it all in level cache 1, up to 80 bits per packet, the measurement of performance is huge.
I think it's very hard to keep things in L1.
Yeah.
Generally speaking, you tend to address L2. The L1 cache is much, much smaller.
Yeah.
Tends to be instructions. My understanding of it tends to be instruction cache, not data.
Gotcha.
That's my understanding. I might be wrong in that.
Yeah.
But cache coherency is really a problem, and it's really a problem with multiprocessing, symmetric multiprocessing. Anybody who's working in low latency will tell you that's. And it's why there's a lot of interest in this thing they're calling NUMA, which is the non-uniform memory access. I think that's what it stands for. Where there's actually a model for dealing with asymmetry between processes and cache coherency. You'll read a lot more about that in the future. Again, I think a lot of the, particularly Intel, is really paying attention to low latency demands.
Yeah.
I think we're going to see a lot more of that. So, yeah, I'd like to hopefully, take those improvements and be able to demonstrate them with a platform like this. Latency sensitivity is, I think where it's all heading, particularly in our sector.
Yeah.
In our domain.
John just asked another question. Do you want to just take this as the last question, or how do you want to do it?
Yeah, go ahead.
Last question, I guess we'll make it. Does Fixate support Iceberg orders? Order type supported?
Again, completely up to you. That's all business code. That's all business logic. That's really up to you to implement that in your application. Fixate will present you with a new order single with the appropriate fields populated. That message has been received from your remote participant, or you are constructing a message to send. Yes, the layer supports anything that's in the fixed schema. Any field type, any message type that's in your fixed schema is supported. Fixate doesn't provide any business logic. That's up to you as the application developer.
Okay. I guess you want to wrap it up then? Yes. Yeah.
Okay.
Wow. Thanks a lot for doing this. Like I said, I mean, for what you do, it takes a lot of years. I know what you're going through. I'll try to build a version of it in Windows and see what I can report back to you. Obviously, it probably sounds like you'd already took a stab at it, but I'll send you over some errors or whatever I come across.
All right. Well, I'll have a look at this trade link thing. I'll see if I can glean what the problem is. It's using quick fix for the adapter.
I think so.
I think it is.
Or it might be using the net. I have to take a look.
Quick fix end. Yeah.
और फिर वहाँ से इन्हें यूरोप के दीगर ममालिक भेजा जाता है। ये एक बहुत बड़ा गैंग है, एक बहुत बड़ा ग्रोह है और
Sorry about that.
Good question.
No, it was just somebody became unmuted somehow. Yeah, so yeah, I can send you over the code for the connector and in the Fix connector and see what you can make of it.
Right. But yes, I think getting it into Windows would be great. I can see that's. Yeah, and I am thinking about it. It's not supported at the moment, but perhaps it will be.
I'm sure
I need some help. Need help.
The user base would mushroom, I'm sure, once you get into Windows, because
yes.
I know a lot here in North America, a lot of the big shops are Windows shops.
Yeah.
And using .NET's pretty prevalent in the industry, so I'll see where it can help out.
Okay.
And I'll get in touch with you regarding that one-on-one, see if this guy out of London wants to participate, if you want to do it.
Yes, that'd be great.
If you're not afraid, he's pretty brutally honest.
That's all right. I don't mind the honesty, as long as he's polite.
Okay, well, I'll send him over the code and see what he thinks.
Okay.
So I guess we'll wrap it up. Thanks so much for doing this, man. I'm sure if
pleasure. It's been great.
Anybody wants to give any shout-outs to David and thanking him and saying he's doing a good job, let him see it all now in the chat mode. Anybody? Please. I guess not. Anyways, but thanks again, man. We'll get in touch. I'll put this up on YouTube, let you know the link and all that stuff. Oh, okay. We got some thank yous from Wujay Park.
Should I be able to see that in your chat? Was it only? Because I can only see.
Oh, you know what? Everybody's sending them to me. That's why. Yeah, I think that's a default that people are doing. Yeah, here.
Oh, it says organizer only. Yeah, right.
Yeah.
In the drop list. Yeah, I see.
Yeah, he says thank you for a great presentation.
Pleasure. As I said, if you want to continue talking about
about it, I'm quite happy to answer emails directly. You know, if you jump over to the site, send me an email. You know, I really want to encourage people to do that. I'd like to keep some sort of dialogue going.
Oh, for sure.
And I won't bite. I'm pretty easygoing.
Yeah. All right, man.
Pretty great.
Okay, man. Thanks again. I'll get in touch with you about all that other stuff. We'll talk about the Windows and this guy, see if he'll do a code review or something. If you want.
Okay, we should probably, you and I should probably have a chat a bit later. I'll probably send you an email and
okay.
we can have a chat later.
Yeah, we can do Skype, whatever you want.
All right.
Even FaceTime. I'm trying to get as modern as possible. All right, man.
I use Tango.
What's that?
Tango is what I've been using.
I've been hearing. I just heard of one called PID. PID.
No, I haven't seen that one either.
No.
All right.
Fast and free is a dream. That's what Ram's saying. Not sure what that is. Oh, right. Fast and free is a dream. Got it.
What's it reminds me of what's on the New Hampshire number plate? Does it say live free or die?
On mine?
No, New Hampshire.
Oh, I don't know.
On the number plate, it says live free or die.
That's a pretty popular saying.
In the States, every number plate, every state has it.
It might be, or it might be Texas. It's one of those. Yeah, I know one of them have one of those type of sayings, especially in the States when they're sitting there with their gun. Of course, who's gonna deny somebody with a shotgun that big, right?
That's where Australia and Canada are very similar.
Yeah, our demographics are very similar, except that you have palm trees and we have snow. That's where we diverge.
We've got desert as well.
Oh yeah, we got desert and snow. Check it out my backyard. That's probably as far as we go. But I'll email you all that stuff about Windows and a guy who will help you out. And I'm sure you might hear back from Andrew as well.
Okay.
Okay.
All right. Thanks very much.
All right. Thanks for coming out, everybody. Have a good night. Thanks again, David. Appreciate it.
See you all. Thank you.
Thank you. See you guys later. Take it easy. I'll let you know about the video recording when it's on YouTube. Hopefully the next day.
Okay, great.
Okay.
It's gonna be highly edited, isn't it?
No, just put it up. I'm like you. Who's got the time to do this? I'm not George Lucas.
Okay, man.
All right, man. Have a good night.
Yeah.
Day for you.
You too.
All right. Take it easy. See you, everybody.
Thank you.
Thank you. Bye.